Okay, so if you still remember, before we have also introduced another model which can do the generation, right? I mean, if you still remember, we have the autoencoder model. It covers both the encoder as well as decoder, right? So decoder part can do the generation of the data instances, actually. Then you may also wonder why we not just use the autoencoder as a generative model or one part as a generative model. So we can show you, the autoencoder again, and we can do a very quick revisit of the autoencoders. So if you still remember, for the autoencoder, given the data input, and we can have one encoder to compress the input data instances into one compact vector like Z as shown here, right? And this compact Z vector can be further fed as input for the decoder as well. This decoder can reconstruct the new data instances, which looks very similar to the inputs, right? So if we define loss function to minimize difference between x and x prime, then we can train the model in an unsupervised way, right? We don't require any enable information. And this decoder part actually defines something like a generative model, right? And if we mask the remaining parts and just focus on the decoder part, and given one vector input, we can feed it as input for decoder. This decoder can generate an image for us, for example, as shown here, right? And this decoder looks like very similar to a generative model. And you may wonder why not just use this autoencoder or this decoder part as a generative model for us, and why we need to care about how to do the generation in the GAN instead. And we can talk about the shortcomings of this decoder part inside the autoencoder and why it cannot work well, and why we need to first consider the proposed generative adversary net. So can we just use autoencoder as a generator? So we may have some problems with autoencoder as a generative model. So first of all, it doesn't really try to simulate the real data. It's just a simulated copy of the input, right? If you still remember what is a generative model, we want to have a new model which can generate the data instances to make the data distribution looks very real to the real world data distribution, right? However, here for the autoencoders, it is just a simulated copy of the input. And what if there is no input? If there is no x input, then this model cannot work anymore because this z relies on this x input, right? So if we don't have x here, then this z cannot be obtained. Then this model will fail to work, right? So if we don't have inputs, then this autoencoder cannot get these embeddings and cannot generate this output. Also, this autoencoder cannot generalize well to some unseen images. And if we do some minor changes to the inputs, this autoencoder can generate very different outputs, right? It will be very sensitive, actually. Also, autoencoder has limited applications in diverse learning settings. Like autoencoder works in an unsupervised manner, but cannot be generalized to diverse learning settings, actually. And because of these shortcomings or problems with autoencoders, and we have to consider a new way to do the generative model, right? And also try to apply them to generate some new cases or new data instances. That's the reason why the autoencoder cannot work well.